So this is the Redox multiple choice questions numbers 9 to 15, with 1 to 8 being in a separate video. So question 9, which of the following redox reactions involves disproportionation? So let's remind ourselves what disproportionation is. It's when atoms of the same element undergo oxidation and reduction, or are oxidized and reduced in the same reaction. And so it's important that we start with atoms of the same element that are in the same oxidation state, and then they change as they go through. So if I look at A, and then chlorine is being reduced and bromine is being oxidized. So that's a classic displacement, not a disproportionation, and that's to do with elemental reactivity and is not a disproportionation. In B, magnesium is being oxidized because it's going from magnesium metal to a 2+ oxidation number, and hydrogen is being reduced because hydrogen, some of the atoms of hydrogen start as +1 and then they become hydrogen gas, which is 0. So they have gone down in oxidation state. So that is just a normal redox. One of each element, so magnesium is being oxidized, hydrogen is reduced, neither of them are doing both. In C, phosphorus is being oxidized, so it's reacting with chlorine. Chlorine is more electronegative, phosphorus will end up in a +5 oxidation state on the right, and chlorine is being reduced because it will end up in a -1 because it's more electronegative. Either way, it's two elements reacting to become a compound, so that's definitely a case where each of those two separate elements will change oxidation number. Even if I didn't work it out, I could see that happening. Let's look at D then. So in D, chlorine starts with an oxidation state of 0. Having a look at the other elements involved, sodium is fixed, must be +1 in a compound. Oxygen we're assuming is -2 and hydrogen +1, so none of those are anything different to what they would normally be. On the right hand side, sodium is +1, and then this atom of chlorine in sodium chloride would therefore be -1. And then the next compound of chlorine, sodium is +1, oxygen is -2, which means that chlorine, this chlorine must be +1. So we are going from 0 in Cl2 to essentially Cl-, which is -1, and ClO-. I can ignore the sodium, it's a spectator ion. And in fact, you can see it sometimes as an ionic equation as well. Without the sodium, it would just be with hydroxide ions, so I thought I'd rewrite it, just to show that the chlorine is being both oxidized and reduced. There were other really big clues that it was D, because D is one of the few ones where atoms of the same element actually end up in different compounds, so that would have been something to look for straight away without even working out the oxidation numbers. Number 10, thought I'd throw in a calculation question. So, making sodium iodate 5 from iodine. So there's my sodium iodate 5, there's my iodine, and I also have some sodium hydroxide information given to me. So I've got a volume and a concentration of sodium hydroxide. So the first thing I can work out is moles of sodium hydroxide because I've got volume and concentration. 50 centimetre cubed over 1,000 to get decimetre cubed, times by 2. That gives me 0.1 moles of sodium hydroxide. So now going to the balanced equation, the thing that I'm trying to find out about is the mass of iodine, so not the mass of sodium iodate, otherwise I would have been given the MR of sodium iodate in a question that was only a multiple choice. So I want the mass of iodine, but first I need to know moles. Looking at the ratio, there are 3 moles of iodine to 6 moles of sodium hydroxide. So that is a 1 to 2 ratio. And so therefore, if I have 0.1 moles of sodium hydroxide, I must have 0.1 over 2 equals 0.05 moles of iodine, which is I2. And so therefore, to get my mass of iodine, it's moles times MR, or the MR. So MR meaning the molecular mass, or the RFM, as it may be in your exam board. 0.05 moles needs to be multiplied by 127 times by 2. And if I put that in my calculator, I get a final answer of 12.7 grams. Now it may be, in fact, you might want to check your working, because it could be congratulating yourself for getting the correct answer by the wrong method. For example, if I had neglected the balanced equation and forgotten to divide by 2, and then neglected the fact that the formula of iodine is I2 and forgotten to multiply by 2, it's actually very feasible that I could have got the right answer to this by making 2 mistakes in a row. That's okay for a multiple choice, but if you were doing a full calculation, you would be losing marks there. Question 11. What is not a correct trend down group 7? So the first ionisation energy of the atom decreases. This is true, and that's because the number of shells increases, and so the attraction between the nucleus and the outer shell electron gets less, and therefore it's easier and lower energy to remove the outer electron. Oxidizing power of the element increases. That is going to be our false one. We will check the other ones though. So oxidizing power of the element means the ability of the element to remove electrons from other substances. So the stronger ability to gain electrons, the better the oxidizing agent. And so fluorine at the top of the group is the most powerful oxidizing agent in the whole periodic table, let alone in that group. Electronegativity of the atom decreases. This is also true for the same reason. First ionization energy and electronegativity follow exactly the same trends because they're both a measure of an atom's ability to attract electrons. Boiling point of the element increases, yes, more electrons, more shells, more instantaneous induced dipoles, so higher boiling point. Question 12. In which one of the following reactions does the metal species undergo reduction? So we're looking for a change in oxidation state just of the metal, getting a lower oxidation state. And it turns out that if I work out A, oxygen adds up to -4, so that is manganese 4 oxide. On the right hand side, that would be manganese 2 chloride, because each chlorine there it's going to be -1 for its oxidation number, so the manganese would be +2. So it turns out that A is the right answer. I can check the other ones. B is quite difficult to look at because that's something you're going to cover in the second year of A level. If you haven't done that yet, that might be a little bit challenging. However, basically how I would work it out, if you are curious, is that water has no charge. And so if the whole of this ion has a 2+ charge, then that means that the copper ion has a 2+ charge. Chloride there, that would be chloride ions because they came from over to the left-hand side. So that's 4 lots of -1. And the whole ion adds up to -2. So again, the copper is +2. This is an example of something called ligand exchange. It's to do with swapping molecules or ions that bond to transition metals. You'll do it when you do the transition metal topic. Part C, we start with chromium in a +6, if you work it out, and actually we end with it in a +6. So this is a rearrangement of the ion, as opposed to an actual redox reaction. And then in D, again, this is not a redox reaction. So we're starting with titanium oxide plus 4, the same as the manganese oxide at the start. But it's going to TiCl4, which is also plus 4. So the actual titanium's not doing anything in that point. It's actually the carbon and the chlorine. So the chlorine's being reduced in this reaction and the carbon's being oxidized. Question 13. Oh, it's another calculation question. So, vanadium and chlorine, brown compound, means nothing, but we have a mass of the compound, so VClX. We're trying to work out what X is, and we have 0.193 grams of it. And then we reacted it with silver nitrate, which is the silver ions producing a precipitate of AgCl. And so I must basically have X number of moles of AgCl produced if I start with 1 mole of VClX. Okay, and I know that the mass of silver chloride is 0.574 grams. So the first thing I can work out is that because that's the mass of silver chloride, I can work out the moles of silver chloride from working out the MR and doing my mass divided by MR. So 0.574. And if I add up the mass of silver and chlorine, you get 143.4 as the molar mass. And that gives me an almost perfect number of moles of 4 times 10 to the minus 3. Certainly to 3 significant figures, it'd be 4.00. So that's my moles of silver chloride. From that, I can now go back and work out how many moles of chlorine, and therefore, well, there must be 4 times 10 to the minus 3 moles of chlorine. Therefore, how many moles of what mass of chlorine is present in VClX? What mass of chlorine is present in my 0.193 grams of VClX? So if I take my 4 times 10 to the minus 3 and I times it by 35.5, I'm only looking at the mass of atoms of chlorine, remember, so I'm looking at the mass of Cl. I don't know how many Cl's there are. It's number of moles multiplied by 35.5, and that gives me 0.142 grams, going off the page here. So I go back to that value there, and I'm now going to do it as an empirical formula. This is a bit of a long question for a multiple choice, so I apologise, but these things happen. So I've worked out 0.142 grams of chlorine is present in 0.193 grams of vanadium chloride. So I've now got a mass, 0.142. I then do 0.193 take away 0.142, and that gives me 0.051 grams of vanadium. I already know that the chlorine is 4 times 10 to the minus 3 moles because I already worked that out. I can now do the 0.051 grams divided by the mass of 1 mole of vanadium to work out the number of moles in that. Turns out vanadium has an atomic mass of 50.9, so when I do 0.051 divided by 50.9, I get basically 1 times 10 to the minus 3, which means I have a 1 to 4 ratio, and it is D. The other way we could have done this is you could just work out the formula mass, so the MR, of the 4 different compounds, VCl, VCl2, VCl3 and VCl4, And then you could have worked out how many moles there would have been in the 0.193 grams and seen how many moles of chlorine were present in that. A little bit trickier. So it is quite a lengthy question for multiple choice, but this does sometimes happen because you get slightly longer to do the multiple choice questions, and some of them, like oxidation numbers, will be a bit quicker. So question 14 is one of those that should take us a bit less time to decide the answer, and in fact it's saying which one is not correct. Less electronegative than chlorine. That is absolutely not correct. So the answer is A, because fluorine is the most electronegative element we have. Just checking on the other ones. Can react with chloride to form chlorine? Yes. That's a displacement reaction. Fluorine is more reactive, a better oxidizing agent. C, forms salts. Of course it forms salts with group 1 metals. All non-metals do. D, it is a gaseous element at room temperature and pressure. Yep, that's true. It's at the top of the group. Very low intermolecular forces. And then the last question, 15. What will you see when a solution of silver nitrate is added to a solution containing bromide ions? So a little bit of recall here. Didn't do anything about this on the video because this is simply stuff that you need to learn about testing for ions and reactions of halides. So the actual answer, if you know your colour changes, then you would have got straight away that it was C, a cream precipitate. The ammonia part is simply an extra check that it dissolves in concentrated aqueous ammonia. Yellow precipitate means iodide. It would not dissolve, so D would be iodide. A white precipitate, well, white precipitate would be chloride, which would dissolve in dilute ammonia, so would definitely dissolve in aqueous ammonia as well. Really worth learning those, and also learning the ionic equations with state symbols, because they are super easy marks for the sake of learning 3 colours and basically 1 ionic equation and a little bit of solubility. Then you've got some really easy guaranteed marks there in the halogens topic.